Welcome back. Have you ever wondered how large-scale distributed systems like Google Spanner ensure every piece of data gets updated constantly, even when spread across multiple servers? The answer lies in atomicity, the principle that ensures a transaction is all in or nothing. Okay, let's try to answer the question about what is exactly atomicity. Atomicity ensures that a transaction updates all partitions of a database or none at all. This is crucial for maintaining data consistency in systems with distributed partitions. But here is the challenge. How do we coordinate updates across different partitions without any conflicts at all? The answer lies in the two-phase commit protocol. To solve this, distributed systems use the two-phase commit protocol, or 2PC for short. It breaks down the process into two distinct phases, the prepare phase and the commit phase. Let's start talk about the prepare phase, and after that we will take an example. The prepare phase, in the prepare phase, the coordinator sends a ready message to all participating partitions, asking if they are ready to commit their transaction. Each partition checks its readiness and responds with either yes or no. If any partition responds with no, the transaction is aborted. The next thing we have the commit phase. Okay. The commit phase, let me put the commit phase here for you guys. So, if all partitions responds with yes, the coordinator processes the commit phase. It sends a commit message to all partitions, instructing them to finalize transaction. Once each partition confirms a commit, the transaction is considered successful. Okay, let's take an example. We have a diagram, the X as example. Let me delete these two. So we have here, the client will initiate a transaction by sending a commit request to the partition coordinator. The coordinator begins the prepare phase, asking partition B and C, asking partition A and C if they are ready. This is represented by the ready message, like ready, ready. If partition A is ready and partition C is ready, both partitions check their readiness response with yes. Now, in the commit phase, the coordinator sends a commit instructions to all partitions, like 6 and 7. You can see in this step. Both partition, once all partitions acknowledged the commit, the coordinator informs the client of a successful transaction with a success message. So if everything went smooth, the coordinator will send will send a success message back to the client. Oh shit. Yep. Yeah. Okay. It will send a request, a successful message or success message back to the client. This ensures that either all partitions are updated or none, or guaranteeing that the atomicity of the transaction. We guarantee that. Why does this matter? Like, why we do all of this? In distributed systems, atomicity ensures that no data is left in inconsistent state, even in the face of failures. The two-phase commit protocol plays a crucial or a critical role in achieving this reliability, making it like cornerstone of distributed database architecture. So, from Google systems like Google Spanner to large-scale databases, Atomicity, powered by 2PC, ensures that the integrity of your data, no matter how complex the transaction is guaranteed. It's yet another example of the brilliant engineering behind the system we rely on every day. So, I guess that's it for this video. We can, I guess, do we need to say anything else? I don't know. I guess that's it for this video. And the next video, I guess we might talk about the consistency in the large, big scale databases. But for now, I guess, yeah, it's done. See you in future videos.